So hey everyone, welcome again to my YouTube channel. Today we are going to solve a new question from our top interview and 50 question series. And the question for today is going to be two sum two input array is sorted. So let's get jump to the question and understand what the question says. So it has been given a one index array of integers numbers that is already sorted in non-decreasing order. We have to find two numbers such that they add up to a specific target number. Let these two number be numbers index 1 and numbers index 2. Here the sequence of the indexes are given. That is, this index 2 is always going to be greater than index 1 and both are in between 1 to nums dot length. Now we have to return the indices of the two numbers, index 1 and index 2, added by 1 as an integer array, index 1 comma index 2 of length 2. So what it is saying is that we have been already given a sorted and decreasing order integer array, and also we have been given a target. What we have to do is that we have to find two indexes, that is which are going to give us the summation equals to target. So if you take this nums index 1 and num index 2 and you sum it, you will get the target value. Now what we have to do is that we have to return this index 1 index 2 by adding 1 to both. So if you get an index equals to 1, you should add 1 to it, that means 2. So you are returning index 1 as 2 in place of 1, and it is saying that we have to return it in a this fashion. That means we have to return in a type of vector. Okay. Now it is given that the tests are already generated such that there is exactly one solution. You may not use the same element twice. Your solution must only use only constant space time. So here it is given that we do not have to use an extra space. So let's see how we can do this question. So this is the first example. Let's understand this example and understand how we can solve this. So here you can see that I've taken that example and here is a target value. I've also mentioned the condition for this, that means our index 1 is always going to less than index 2. Now let's think how we can solve this. So how you can get this number 9, let's see. So if you try to add this 2 and 7, what you will get? 9. So these are the two values which are going to give the answer in this case. So our answer index is going to be, first index is going to be 0 and second index is going to be 1. But you do not have to return 0 1. You have to return adding 1 to both. That means you are going to return 1 comma 2. So this is our requirement and this is what we have to return. Now let's see how we can solve this question. So to solve this question, what we can do is that we can start by taking two pointer, one from start index and one at the ending last index. And why I have taken is that it is already given that our index 1 is always less than index 2. So we are assuming that our index 1 is going to be this one and our index 2 is going to be this one. So by assuming this, we are going to start our loop, and what we do in this loop is that we are going to check until the position where our I1 is less than I2. So until our I1 is less than I2, we are going to search in this number integer array. And what we are going to do is that we are going to iterate until this condition, and we are going to check at every step that if the summation is equals to this target value, then what we have to do, we have to simply return by adding 1 to both the indexes. Now, if there are two cases arise, first assume that the summation is less than our target value, and the second is going to be when it is less than our target value. So there are two conditions left. If it is equal, we return the answer, and if it is less and if it is greater, what we have to do is that, let's see. So let's assume that you are adding these two, that means 15 plus 2. So our target is 9 here and the summation is going to be 17, which is greater. So if it is greater, what we do, we decrease our I2. We take it to this position. And why is that? Because when you decrease it, our summation is going to decrease, overall summation. But if you increase our I1, then our summation is going to increase because it is already in sorted order. So we are going to use this concept, and when our summation is going to be greater than target, we are going to decrease our I2, and if it is less, then we are going to increase our I1. So this is the approach which we are going to follow to solve this question. So let's get to the code and understand how we can solve. So let's start, and let's start by taking a value L which is equals to nums dot size, and after that we are going to take two pointers. First is going to be I equals to 0 and j is equals to L minus 1. So these two are our pointers for our traversal. That means first at the first index and second at the last index. Now we are going to run a while loop until our I is less than j. So now we have to check some condition. So first condition is going to be when our nums I plus our nums j is equals to target. So this is our final output which we want. So what we do, we simply return, and we are going to return I plus 1 comma j plus 1. So here what we have done is that we have not stored our values in a vector, we have directly returned it. So we have satisfied this condition that your solution must use only constant extra space. Now let's check another condition, which is else if. And here what is going to happen is that when our value is greater than target. So we are checking when our value is greater than target. So if it is greater than target, so to decrease it, what we do, we decrease our j minus minus. Now last condition, that is when our value is less. So if it is less, what we do, we increase our I plus plus. Now if all this loops is complete, so if we do not able to find this value, that means when it is equal, so what we return, we simply return an empty vector. So we return this. Now let's run this code and check if it is correct. Okay, so it is accepted. Now let's submit this code. Okay, so it is successfully submitted. So this is the question for today. Thank you all.